Good afternoon to those of you guys out on the West Coast, and to good evening to those of you on the East Coast, and whatever it is for us in the middle. I'm happy to be here. I'm your host, Curtis Brown. Welcome to TI Office Hours. This will be a time crunch edition. I promise we will not try to talk like Alvin and the Chipmunks. But we are going to talk really fast here and try to get as much done as we can in this short period of time. I'm joined here by Randy Munch and Jennifer Waters. Super excited that they're able to join us this afternoon and share some calculator expertise with us, focused on AP Calculus this evening. But before we get started, just again, I want to express my thanks and gratitude to all of you teachers out there who are working in this incredibly difficult and strange time, trying to get your kids taught this material in this time is super challenging. And to you students who are out there watching this, the same thing. I super support you, and I know it's difficult and tough, and I'm really glad you're making the effort to invest in your learning. So anyway, I want to make sure that we put that out there and say that, but before we get started. So Jen, I think you are starting us this evening. So if you want to, you can go ahead and share your screen and take it away.
All right, well, hello there, students and staff. Really excited to be here as we kind of do our flyby on the TI-84. When you download your emulator software, there's just some things that you should definitely take note of when we look at our keyboard versus our touchpad versus a physical mouse. So when you have this, it's important to know that your keyboard does not work as normal. So if you're going to be using this calculator, make sure you are always clicking these buttons, even if you're on a touch screen. Just like a normal handheld, this screen right here is not touch. So everything that we want to do does require physically touching these buttons. So let's look at this emulator software. Over here on the top left, you have an option of clicking the calculator you are most used to using. If that's the color edition or the C or the plus version, I recommend choosing one that you've used in your classroom or that you're most comfortable with. Over here, I have my key press history in case I want to see what I've done recently. And something that is new to me is this little preview. So any graph that you've recently done or table will pop up here on the side in case you don't want to flip back and forth constantly. So I'm going to take that off, and we're going to look at some of these control features. This allows me to change my keys from left to right. And my little pull toggle here can change the size of my screen and my keys. So it's important to make your window screen at a comfortable situation for the kind of equipment that you're using, whether it's a laptop or a tablet. So let's look at some important features specific to your AP Calc exam. One, let's make sure that you're always in radians. So if you click on that mode button, again, it's really important to scroll up and down using those side arrows and up and down arrows. All right, and then I'm going to go second mode to quit out of that. Next, we're going to look at our graphing window. So up here, if I click on the window button, again, I want to scroll up and down, making sure that I use that negative sign instead of the subtraction. When you click graph, it will update it for you. And next, if I were to go into our options for a graph, say I decide that I want to graph x plus 3 and negative 2x, again using that negative button, and I hit that graph feature. Now there's something really neat about the 84 that allows you to look for the intersection of something. Now you can apply this to higher calculus skills, but we're using easy functions on purpose. So the important buttons you need to know are second and trace. So if I go second trace, notice number 5 is the intersection. When you click on that number 5, it's going to ask you to confirm both of your functions. Clicking enter to confirm the first, clicking enter to confirm the second, and clicking enter to look for the intersection, and it does provide it for you. Another great feature of your graphing screen, I'm going to go back to my y equals button. I'm going to hit that clear, go back up to the top, and this time I'm going to use x squared. And now I'm going to hit that graph button. Now, say you want to see the derivative at a point graphically. So I learned this today, which was really exciting. If I go to second trace and I go down to my derivative feature, number 6, I can choose a derivative, say at 3. Typing that number 3 and hitting the enter button tells me the location as well as the derivative. And so that's being able to see things graphically if you want to get into that understanding while taking that exam. And I'm going to quit this out and go back to my main calculator screen. It's important to know where your templates are. So when you're looking at your templates, you're always going to click on that math button. And notice if I choose number 8, that gives me the derivative at a point. I'm going to hit that clear button. And the last one I'm going to show you is click on that math button again, type in that number 9, and that gives me my definite integral. And so that's kind of your flyby on the TI-84. And I'm going to stop sharing my screen. And now we're going to pop over to the Nspire, which is my besties, Randy Munch.
Thanks, Jen. Hey, really quick, we did get a couple of comments in there. Wanted to just pass along that Peter Belita says, hey, Miss Munch and Miss Waters, you guys rock. And super want to make sure you guys saw that. Reminder to anybody who's watching us here, you can post questions and comments in the comments section there. We're looking forward to answering those as we go along through this time. So make sure if you've got questions or if you've got a tip or something that you want us to think about, please post those in there and we will get to them as quick as we can.
Am I up?
You're up.
All right, so I can't promise not to speak like a chipmunk because I get really excited when I talk about calculus, but the good thing is that it is recorded. So if I go too fast and you want to replay it, you're welcome to do that. So the first thing is I'm working on the Nspire CX student software. I normally work on the teacher version, but since this is what the students have available to them, this is what we're going to go off of. Like Ms. Waters showed you on the 84, one of the really nice things is that I can enlarge this. So I have a very large calculator screen. One of the nice things that I really encourage my kids to do when they have this on the computer is that they can use the keyboard. So when I want to type in things, they can use the keyboard or they can use the clicking feature of pushing the buttons. I always tell my kids to start a new document and we're going to start with a calculator. And before we do anything, there's a couple things that I want to point out on here. For the students who aren't used to the emulator software, the insert button will allow you to insert a problem really quickly. So for those multiple questions that you're going to go back and forth on, that problem feature is really nice so that I can go second problem, first problem. Most of the time my kids have to push Control Dock for that. So that's a really nice feature that's on the computer software. The other feature that I want to point out is this toolbox up here. So this will give you the menu key. And Miss Waters always likes to joke that the menu key is her best friend. And then I get sad and I cry. And then I just buy her ice cream and now I'm her best friend again. And this is the slide sorter. This is really useful if you want to toggle back and forth between screens. At the end, I kind of want to give my perspective as a teacher from what's helpful for this before we take the AP test. And so this is a screen that I'm going to reference a little bit later, but right now I want to be pushing the keys and hopefully those are large enough for everybody. They're certainly large enough for me and my poor vision. So I want to quickly go through the 4 things that you need to be able to do. And at this point, most of my students are pretty comfortable doing those things on a calculator, but doing it on an emulator, there's some keystrokes that make it a little bit easier, and I want to go over those. So first and foremost, I'm going to use the keyboard because when kids are typing on here, they tend to go slow, and we're all about quickness of time. So I'm going to type G of X, and my kids call this the magic button. Control library to get the defined as, and then I'm going to use x squared, which is not a very exciting function, but we're kind of going more for what does the calculator do and not how fast can I type for right now. I'm also going to share something that I do with my kids that you may or may not find helpful. I'm going to define G1 of x. And I'm going to define that as the first derivative. One of the really nice features about the Nspire is that you can use letters other than y. So on the AP test, if they give you a function called g, or if you're working on the BC test in parametric, you can call it x of t, you can call it y of t. So I have my kids label things G1 for the first derivative. And then in the menu button, I always tell my kids, where did we learn derivatives? Well, we learned them in calculus. So I'm going to go to the calculus. And you'll see there's your derivative at a point. If you're working on a CX or a CAS, those are going to be a little bit different just because of the computer algebra software. But when I do this on the CAS version, I have my kids define that. I'm not going to worry about that for right now, but I'm just going to define that because one of the things that they need to be able to do is graph in an appropriate window. So I'm going to come up here using the computer software, and I'm going to add a graphs page. And then over here, I already have this stored as the function g. So I'm going to type in g of x because that's what the calculator recognizes as your independent variable. And then one of the really nice things that I like about this is right here, if I right click, you get this context menu. And I'm going to go to the attributes and I'm going to change that label to now y equals g of x, because I know this is something that the kids see a lot of on the test, y equals f of x for a particular solution. And that's something I like to give my kids the visualization of. And so the first thing that they need to be able to do is graph an appropriate window. And so you can do that through the standard method of menu window, and you can change your window settings. But if I escape out of here, and if I just double click on this, that's going to let me change the window, and I can tab around to do that. So that's one skill. The next skill is going to be solving derivatives at a point. And again, that's where we go back to that menu and the calculus key numerical derivative at a point. So when I click on derivative at a point, it's going to ask me what variable do I want to use, what value. So Ms. Waters did x squared at 2. So I'm going to type 2. And it's going to ask me what function do I want. So I'm going to come back here and I'm going to go to the var and I'm going to push g of x. And it's going to give me that derivative. One of the things that I've seen a lot on the AP teacher Facebook page is whether or not we're going to be able to use or how much we're going to be able to use calculators on the test. I heard somebody use the phrase calculator agnostic, and I thought that was pretty clever, and I wish I knew who started that because I've been using that a lot with my kids. And so I think it's important to point out that when I use this with my kids to teach them something versus how do you take the test on this, there's different skills that I use. So when I have my kids learn this, I do a lot with that on a graphs page. For the test, I want them to be able to quickly do things. So for me, part of what I'm going to be using my kids, using the software with my kids for, is for them to be able to compute these things very quickly. The other thing that's a nice feature, and Ms. Waters was talking about a point of intersection. So I am going to come up here and I'm going to push the tab to get that graph line back. And I'm just going to push 4.5 because if I want to know where this function equals some weird number, I'm just going to graph and guess. Whoops, not what I want to do. There's a nice feature right here, undo, in case you do something you do not want to do. I want to look for the point of intersection, and my kids struggle with this a lot on the handheld. It's really nice on the software because if you go menu, now you're not, excuse me, when you go menu, analyze graph, intersection, you get this lower bound, and the kids really struggle with this on the handheld the first couple of the times. On a computer software, it's really nice because they just have a mouse. So when I click once and I scroll over, it's going to give me, I call it a ghost. It's going to ghost what that intersection is. If I want the other intersection, then if I keep going, it's going to show me the other one. So if I want this one, I'll leave it. And if I want that one, I'll click. If I hover over this and I push the plus key, it's going to give me those more significant digits that we need. And when we do the calculus, we work with 5. And if I want more, I can keep pushing plus. The other nice thing that's really helpful on here is if I want to store that number to use it, I click on it, I go control store, and then whatever I want to store that as, I'll store it as B. And you'll notice it becomes bold. So over here, B, and it recognizes that feature. The last thing that your kids need to be able to do on a calculator for the test is to be able to do a definite integral. And so again, that menu key is our best friend. Where did you learn to do an integral? Calculus. I'm a numerical integral, and that's where you would plug in if I want 0 to 2.5 of my function g of x at x. And there I can do my numerical integral. And so that's the required skills for a kid to be able to do on the AP test. But I wanted to point out a couple things that are going to be helpful for me as a teacher. This was our first week back in distance learning. So a couple things that have been really helpful for me is the TI website. So this is where the kids will go to find that software, but there's also resources that they can go to. This will be a wealth of information for me as I get back into the swing of things. I just wanted to point out one last thing before I turn it over for questions. And this is where I'm hoping to kind of get some audience participation, because I haven't done this yet with my kids. And so any feedback you guys have is going to be great. When I teach my kids, I try and give them a graphical approach, and then we harden it up to that solid algebra. And now as we go back, knowing that the calculus test is really going to be focused more on, do they understand the calculus and not can they Google something? I'm going to go back and do some more connections with my kids. And so I just wanted to show this one thing and get your guys' feedback with slope fields, because with the short amount of time we have left, I would like this calculator to help me help my kids visualize a variety of things. So the first thing I'm going to do is I'm going to insert a graph, and I want to look at a slope field. So I'm going to come down here and I'm going to change to a differential equation. And if you're a BC teacher, you will recognize this function. And if you're an AB teacher, it's still an excellent function to look at. So I'm going to do y1 over 14 and 7 minus y1. And in a differential equation, when you're writing a slope field, this gets me every time I teach. So this guy right here is the prime. So my variable is y1. So I have to type in y1, otherwise it's not going to do anything for me. So now I've graphed a slope field, and it's not very interesting. So I'm going to kind of adjust this window until I get to see what I want to see. And this is really something that comes with practice. I know what I want because I've done this a whole bunch of times. I'm also going to scoot this. And so now what we're looking at is a slope field, and there's a couple things that I want to hit on. And so for those of you who are calculus teachers in the chat, I'd like your feedback about what kinds of questions you would add to this, or if you like or don't like my questions. So normally I have my kids have these on paper and we put wiki sticks down, but for now, I'm just going to use my screen snipping tool, and I'm going to take a snip of these that are in a horizontal line, so that when I look at these, and I'm just going to add a notes page so I don't have to keep switching back and forth. I would ask my kids something about, do these slopes change? Are they increasing? Are they decreasing? Are they constant? And I would have them talk about, does X matter? Or in this case, if it's a logistic growth function, does time matter? Or is it the population? And so now I can really get my kids to hone into that horizontal slope. Does X matter? I can also really nicely look at the vertical slopes, and I'll just grab those. Let me shrink this up. And so we can talk about, does the slope change when Y changes? And we can talk about, is the slope increasing? Is the slope decreasing? And there's a lot of good vocabulary that helps me, or hopefully is going to help me, distinguish between, do my kids understand what the function is doing, or do the kids understand what the slopes are doing? Because when I look at this graph as a logistic growth curve for BC, I'm looking at concavity, I'm looking at points of inflection. When I look at this slope field as an AB teacher and graphing those slopes, we can talk about, well, what's a relative slope? If the slope should be 1 here and 2 here, do those look like different slopes? And so I'd love to get any other questions that you guys might ask on a screen like this that would help connect those with kids. The last thing that I want to talk about, if Curtis has any questions, feel free to interrupt me, Curtis.
I do actually. So
Okay.
it's related to this slope field piece, as a matter of fact.
Okay. I have another slope field too, because I just
But
went
I
crazy
need,
on
no,
slope
it's
field.
not this particular slope field. More,
Okay.
it's more of a general question. And in fact, I'm going to go ahead and share my screen really quick because to
Okay.
answer the question, I probably need to have that sharing.
Okay.
See
So
my website
I'm
You know
there.
gonna.
what? While Curtis is doing that, I'm going to share the math inspired page.
Okay, cool.
And because that's something that I think Randy was going for earlier.
Yes.
Yep.
Okay. So what she's talking about here is over here.
Sorry. There you go, Jen. Now you're sharing.
Oh,
My bad.
perfect. Okay.
Can we practice this?
When we are on our TI website here, up at the top, you're going to see activities as well as our math inspired here. And there is stuff for the 84. You just have to build it on your own as opposed to having it pre-built and sent out. And if we click on calculus, we can look at different items here. What I love about these activities, it's not about finding a numerical value. It's about the deeper understanding of that topic. So if you want your kids to really be able to delve into, limits of functions or derivatives,
Hey,
or just
Jen.
see it in a different way, what's that?
Something happened with your screen share, and we're only seeing a little blue bar. So
We're only seeing a little resume share. Can you see it now?
We're good now.
Okay. I love technical fun. Welcome to distance learning.
At least I didn't say the derivative of sine is tangent.
No problem. All right. So again, TI website, clicking on activities, going down to math inspired. And then notice there's some for all of the subjects. And if I click on statistics, I wish, next week, calculus, these are all of our topics. And these really focus on getting that understanding down. So if you know students who are struggling on a particular topic, you can send them great activities for them to try on their calculator software. And it's a lot easier to do these activities on the software than it would be for the handheld. So I would definitely take advantage of these if that is something that your students have time for before that exam.
Awesome, Jen. Hey, really quickly, will you, if you'll stop sharing, I'm going to share my screen real quick.
Definitely. It is on.
Related to the Randy, there was a question about whether or not we could do slope fields on the 84. And the answer to that question is yes, you can, but it requires a program to be able to do it. It doesn't have an embedded feature capability on the 84 to manage that. And so I wanted to make sure that I made everyone aware of the place where you could download a version of, there's probably many of these out there, but there is a version of a slope field program out here. If you navigate to the education.ti.com webpage and you click on the resources tab, there's a section of the website called TI in Focus. It's a project that TI has been working on for the past 3 years. We've been fortunate enough to have Steve Kokoska, former chief reader Steve Kokoska, and Tom Dick, who was a calculus committee chair, test development committee chair, work on a project where they reviewed the last free response questions for the last 3 years, and they've posted videos for all of those on the TI website, some with scoring and common errors and other things. If you click on the resources page and get to that website and navigate to the ABBC4 for 2017, we have that 84 plus CE file posted here, and you can download that and store it in your 84 calculators and be able to use a slope field and do some of the really cool stuff that Randy was showing us just a moment ago on an 84, which is really kind of cool. And Randy, I did learn something new today. You told me that
that's not even the thing that I was going to teach you.
I was super excited to see how you use the notes page and the snippet to paste in pictures like that. That was really nice. So I'm going to stop sharing. If you're ready to kind of keep going with what your topics were,
I am ready to keep going. Nope. Now I'm ready. So I created another slope field, and this one may or may not be recognizable by just the line here. But my students struggle understanding how the second derivative and the first derivative relate to concavity, whether the first derivative is increasing and what that means in terms of concavity. So here I have a visual that my kids can tell me, oh, the slopes are becoming more positive. More positive leads to increasing. So the derivative is increasing. And then when I come back here to where I took that slope field, or I took that SNP from, the kids can see, oh, hopefully they recognize that this makes the x squared shape. And the last thing that I'm going to have my kids do, I have not had them do this yet, so any feedback in the chat, fantastic, is I'm going to have my kids use geometry and the points and lines, because my kids struggle if they don't have that like physical object of the wiki stick in front of them. And I'm going to have them create segments. And I'm just going to have them start at a point and extend that until they kind of get to the next row. And then as long as they keep extending that, they'll see, and I'm not going to do a very good job of this. Whoa. But they can kind of start to trace what that solution curve would look like, in addition to being able to see a list of particular solutions. Because the other thing my kids struggle with is particular solutions. So I'm going to graph a couple of these, if I can type correctly. And this also really helps my kids solidify what that plus C value means when we talk about the initial condition. And so I haven't done this with my kids. And this will be something new that I show them in the coming weeks to help kind of connect those things. And the last thing, Curtis, this is what I thought I was going to teach you, but it may or may not be helpful. So I'm in a Word document, and I'm going to make this very large. And I'm going to state a fact that I know about Curtis. Curtis Brown enjoys all graphing things. And I learned that in Word, there is a font for the keys. So when I go to create things for my kids to do during distance learning, I'm going to use this to help me create job aids. And the last piece that I'm going to use is this slide sorter over here. So when I look at this screen and I want my kids, if I can't interact with them directly, I'm going to copy that page. See if I can do this like this. I'm going to copy that page and just transfer it over here so that when I create things for my students to use in these next couple weeks while we're preparing, if they can or cannot meet with me face to face, this is something that I'm definitely going to use as a tool in my next couple weeks of instruction so that I do my best for those kids.
Ooh.
And guess what?
I
The
see a hand
same
raised.
things work for the 84. So if you have a Word document open and you drag across your screen from the emulator, it'll do the same thing that she just did with the Nspire screen. As well, if you show the key press history, you can use the same tabs to make a job aid for your students. So that's something that works on both platforms.
Yep, that's a really nice feature. And you're using the fonts that are installed automatically whenever you install the software on your computers, which is really, really cool. So that's a cool feature. Thank you for sharing that really quickly. There's one more thing that I saw, and you can do this on both platforms. Earlier, you were talking about that you had defined this function g of x, and you started to define the derivative out of, or derivative of g of x. So go ahead and do that. Go ahead and say, okay, I define g1 of x as the derivative of g of x or something like that. So we're going to do.
I have my kids do the shift minus.
Nice.
But it's also in the templates key over here. I like shift minus because it reminds them of the power rule. We drop down a power, and then the integral is shift plus. So dx variable g of x.
At x. Now, you went too fast for me. You're in numeric. You're in the numeric software. Is that correct?
I am. Would you like me to open the CAS software?
No, I want you to do it this way, and we're going to do it with a. We're going to do it numerically, though. So I want you to use the numerical version. By the way, you just taught me something else I didn't know. Minus.
I love when I teach Curtis something. It's the highlight of the day.
calculus, so G1 of X is defined as calculus, the numeric derivative at a point. So snag that really quick.
Okay.
So, and the value is going to be X.
The value is going to be X.
Mm-hmm. You have to define this first. I apologize. I'm walking you through something we should have rehearsed earlier. So cancel.
So I'm guessing
what do you want me
to define X as a numerical value first.
Yeah, hit cancel.
Okay. So
go up and grab your G1 of X.
This one?
Yep.
Okay.
Define that as a numerical derivative at a point.
Okay. Control, define as the numerical derivative. So you want to go menu, calculus, numerical derivative?
Yeah, and now you should be able to define it as a point.
As X?
At X. Mm-hmm. Okay, it let me do this earlier.
So Curtis, I'm going to tell you about the trap that I always get in because I work on a cast normally, and then I try and show cool stuff, and I'm like, oh, how does this work on a CX?
Okay, we got this really interesting question that just popped up actually while we were doing this. I'm going to change the subject really fast.
Alrighty.
Would you recommend having students use a handheld calculator or the computer calculator if possible, since the computer version is free to download right now?
I would recommend having the kid use what they're comfortable with. I have some kids who are faster on a handheld than I am on the computer. And if that is the kid's case, use the handheld. I also have some kids who have some hand-eye coordination problems because they're teenagers and sometimes they can work a phone real quick, but a calculator is struggling. So for those kids, I'm suggesting that they get on the software and practice on the software. But I would say whatever they are most comfortable using on exam day.
I think the biggest recommendation is don't plan on using the software if you downloaded it an hour ago.
Yeah.
So if that's something you're going to try using, because you can make a screen bigger or you can see multiple screens at a time, give yourself practice time with it, try a couple problems and make sure you're comfortable. You don't want to be in a time crunch using software for the very first time.
Yep.
Good point. And the link for the software has just been posted on the chat just now, so should be in the comment section there. Last couple of things, since we haven't gotten a ton of other questions, and so I think I'm going to go ahead and get us wrapped up here. Two things I want to kind of make note. First of all, I don't know if anybody has made notice of my fantastic Zoom background, but I have a virtual background that's posted here, and we can.
First, you always stop sharing so people can see it.
If you go to at TI Calculators and follow us on Twitter, we'll have some fun backgrounds soon, ready to go. And so you should be able to do that. Also, we've done a few of these office hours, and so our YouTube channel is a great place to get some more information, both on some calculator tips, some videos that way, and then also just some tips for this AP exam, these ones coming up. We've had some great experts come on and talk specifically towards those exams. We've got another one coming up next Wednesday at 6 p.m. and another one of these time crunch ones happening at, I guess it would be 5 Central.
Team statistics.
Pacific.
Calculus.
Team statistics next week for that. So I'm looking forward to that. And anyway, I just want to wrap up one more time thanking you teachers for the hard work you're doing in this really incredibly difficult time. So thank you, Jennifer and Randy, for joining us and sharing your expertise. I appreciate it much.
Thank you. Hopefully everybody learned something.
Thanks, guys.
Bye-bye.